Okay, welcome everybody. I am super happy to be here. I think the other speakers don't say it enough. We are standing on the largest particle collider in the world. I'm totally amazed. I'm Lisa. I work as head of AI in a company that creates software for drug development and gene technology. And I'm also a core team member of the LangChain4j framework. So this is our team. The library was created by Dmytro Liobarsky, and now the team has grown to plenty of people contributing on GitHub. We're open source. And we provide an easy way to integrate with LLMs and also now image models in your Java application. Just a question, who has already used LLMs? That's kind of disappointing. That's only half of people. Who uses an AI assistant when coding? Okay, also half. Who has already created apps or experimented with apps that use LLMs inside? Good, that's about 15 people. That's very nice. I hope today you will learn new things, and for all the other people, brace yourself, because you should know how to do it when we're done with this talk. So LangChain4j is inspired by the LangChain library. It's a very popular library in Python that allows for easy interactions with the zoo of models out there, and to build a lot of things on top, like agents, like document chats and everything. And it has one big disadvantage, it's that it's in Python. And it's even so popular that a lot of people switched to Python just in order to use this library. So it was high time that we made this for Java. What LangChain4j allows is to build things on top of LLMs. So we start with the LLM a bit as your basis, as your infrastructure. And I think Dimitris Andreadis, who has a talk after, he said this very well. This whole artificial intelligence world is splitting in two levels. There's at one side this building of models, training of models, fine-tuning them, which is often data scientists doing it. And then there's this other level that comes on top that's just emerging, that is actually to use them in your applications, and that's more for us developers. That's more fun. So just to get our terminology straight here, I'm sure you had already a lot of talks learning the difference between language models and everything. What we mean in LangChain4j with a language model is just your completion model. Then we have a chat model. So most providers now also have a chat model that really wants to chat with you. And then a very different thing is an embedding model. It's actually a sub-part that is used in language models. It will change your text, your input prompt, into a vector of numbers that kind of encode the meaning. And then these vectors or embeddings, we store them in a specialized database called an embedding store. There was a very nice talk yesterday about the use of these embedding stores. They're specifically optimized to really retrieve very fast a similar vector with a similar meaning. So if you can retrieve things with a similar meaning, it means it's very nice to find relevant pieces of information, because you find the things that have this similar content, and also to characterize, like everything that's read, to divide your data in different parts. You can also just use your embedding model, and you don't have to use the whole language model on top. So with LangChain4j, we aim at making this access to all these models and building applications on top a piece of cake. Okay, LangChain4j, here are our base components. So down there we have the basics, language models, and now also image models. Prompt templates for easier interaction, so you don't have to write a whole prompt around it all the time, but you can just put variables in there. Parsers of the outputs. We have a memory, so we can actually chat with it, and then it can access tools. At the other side, you see RAG, a retrieval augmented generation. That's a hard word to say, chat with your documents. I will come back into detail later. And then the level on top, we have a higher abstraction level where we group all these basic components into chains or AI services. We provide integrations with most, the biggest commercial and open source model providers. So we have OpenAI, we have Azure, we have Google, Palm, and Gemini. And then we have these couple of special ones, local AI and Olama, that allow you to run a model locally and still access this via API. So then you can run whatever model you want, fine-tuned or just open source right away, in LangChain4j. And then there's HuggingFace, which is really interesting. It's a community and a website where you can access lots of open source models. You can see a lot of things that other people fine-tuned. They provide a lot of leaderboards to compare which model you need for which applications, and you can then also fine-tune and train your own models. They also provide huge data sets. It's really interesting. And then you deploy your model there, and you can integrate it in LangChain4j like that. Image models, for the moment, it's DAL-E. More are coming. Then we have a list of embedding stores. I'm not going to go over it, but it's when you want to store these embedding vectors. We have document loaders that we will need for our chat with documents. We have code execution engines. I'll come back to that later. That's really fun. And then we integrate with Quarkus and Spring Boot frameworks. Right, let's dive into a little demo. So first thing first, at the end of the presentation, it will be a big QR code that leads you to our repo, but here it's not hard to find, LangChain4j, just LangChain4j. And from there, you can find everything else. So under the code here in our README, there's our Discord channel, in case you want to interact with the community, or you can file issues and discussions right on the GitHub repository. There's code examples linked here, also for Spring Boot, also for Quarkus, and then a link to our documentation here. Oh no. That's going to be a problem when I want to be talking to OpenAI. Please. Yes. Good. So our documentation is kind of in the making. You find all these integrations, for example, all under here. And then more details are coming soon. OK, so for the demo, I have for you a Spring Boot example here, a customer support application that will chat with our customer and allows the customer to make bookings and to cancel bookings and to update bookings. And it knows also our terms of use. And it has some tools that allow it to check if the booking actually exists, and then it will compare with our terms of use if it can actually cancel the booking. So I will run this. All these examples you will find under the tutorials folder in our example repository. That's also linked from our main repository. So I'm the user, and I want to cancel my booking. And what's happening is that it knows it has some tools to do this, and it also knows that before it can do it, it needs my information. So it asks, I can assist you with that. Could you please provide me with your booking number as well as your name and surname? So let's say I am Klaus Heisler, and I forget my booking number on purpose. So now it's going to check if it has everything it needs to know. But it says, thank you. But I also need your booking number. So I'm not going to give the whole demo here, but if I would put the wrong booking number, it can retrieve the bookings from our database, and it will say it didn't find it. This is some logging going on here. We provide an exception that the booking cannot be cancelled with the reason, and then it matches it with our terms of use, and it will say, it appears that this booking cannot be cancelled. Let's try. So usually it tells me why. Let's see if it can do. So the reason is that the booking period that I have is less than 3 days from today. And so we cannot cancel it. That's really nice. Now, I'm really sad about that. So I will ask it. This is a nice thing about LLMs. They won't get angry no matter how many mistakes I make. And I should have asked it to be short, because the longer its output will be, the longer it takes to wait for it. I feel a lot is coming here. There we go. I'm truly sorry to hear that you're feeling this way. It's always tough when plans don't work out as expected. Yeah, I mean, this is awesome. So this is how it works. Now, I would like to build it up step by step after killing my assistant. Good. So we're going to take it from the start. We're going to try to write a hello Vox days. And I was strongly disadvised to do live coding in a conference, but this is just too easy, so I will do it. So first we will need a chat language model. And for the ease of use, we're going to use an OpenAI one, especially with this auto-completion. It got so easy. So you can use any type of model there, and if you want to support some model provider that we don't have an integration with yet, feel free to make a pull request and add it. The only thing we really need is our key, and I've stored this in this file. There's also a demo key available if you just want to try it out a bit. There's a little quota. You can put a string demo in there instead, and it will work. And then from there, let's store our results. This is model.generate, and we want to make it say, hello, Voxed days. Let's see. Oh, and then we're going to print it. Exactly. Let's see what happens if we run this. Wow. Wow. Okay, no. All right, let's try this again. Wow, that's amazing. Okay, I'm puzzled. Excellent. Yeah, no, I mean, wow. Okay, this is the worst performance ever. Wow. Just starts make me wonder if I'm running the right code here. I'm baffled. God. Yeah, wow. No, Jesus. Okay, we're gonna call it demo effect and okay, let me just try my next example. See if it says something else in Hello World. Okay, this is really bad. Yeah, I'm gonna do that. Oh God. So okay. Somebody has a suggestion here? Like I would close the whole thing and reload it? Great developer practice. Yeah, I'll try that. Yeah, I'll do stop and rerun. This one is an image generator, so it takes longer. Hey, while we're waiting, first thing, even if I was running the, yeah, this is nice. Okay. Sorry for that one. So we have, what's my name now? No. I don't get it. Anyway, I think my next slide anyway applies. One does not simply get... So, yeah, I'm not sure what's happening here. But even if it was running correctly, it would probably say, hello, Vox Days, how can I assist you today? And so one thing is, it's not deterministic what is going to come out of this LLM, and it's hard to steer. So in general, you should pay really attention to what prompts you put in there. So next thing I wanted to show is how you can set the model parameters here. So if you use this builder, you get all options of parameters that this model has. So this is specific to the OpenAI one, but our other models have similar builders. And then you can see what the parameters stand for either on the provider's website or soon to come on our documentation website too. Yeah, we ran the image model. Too bad we lost it. So I try this again. So image model is just as simple. We just specify that we want DAL-E3 here because DAL-E2 is really bad. We again set our key, and then we have a model where we again generate. And my prompt was, Swiss software developers with cheese fondue, a parrot, and a cup of coffee. And now let's see what it made out of that. Inclusive and all, right? I really like it. So that's how you use our image models. There is a prompt template class here that you can have a look at home to actually use variables in your prompt, making it a bit easier. So I don't have time to run all the examples, even if they had run properly. So I'll just take out the most interesting ones, and the other ones you can follow the tutorial on our documentation, or you can just look through the example folder. So the next interesting thing is streaming. Normally there's a lot of text coming out of these LLMs, and to sit around and wait for half a minute for it to appear is quite annoying. It gets much more interesting if you can read along, if it outputs all these tokens. So then we also have streaming versions of our chat models, and you just put streaming in everywhere. Now, what does it mean token per token? The token length, what a token is a bit depending on your model provider, but it's general around 3 characters. So I'm going to count these tokens for this model, and I'm also going to output the full number of chars so we can have a look. And then when we want to generate with a streaming model, we will need a streaming response handler on top of our normal prompt. So then we define what happens on next. We will print a token in this case, on complete, on error. And then let's see what happens. Write a short, funny poem about developers and null pointers. I'm gonna make it 5 lines maximum because it doesn't listen very well. It usually gives me like 15 lines. Or it will say hello world. Okay, so we have 23 tokens for 77 characters. And it's not listening at all. Right. So in the realm of code where developers dwell, there's a tale of null pointers that I must tell. With a swift keystroke, they cause quite a fright, leaving devs puzzled day and night. Null here, null there, null everywhere, yeah. Oh, how it haunts us, this sneaky affair. Like a ghost in the machine, it wreaks havoc galore, leaving us scratching our heads, wanting more. No. But fear not, fellow coders, for we shall prevail. With debugging skills, we'll surely unveil. We'll chase those nulls like a cat after a mouse and conquer the bugs that lurk in our house. So let's toast to the null pointers, a mischievous bunch, for they keep us on our toes with every hunch. But remember, dear devs, in the midst of the chase, laughter and perseverance will bring us grace. It's something, right? But usually it gives me this kind of feeling when ChatGPT tries to make jokes. So if any of you has time to match, please take your favorite comedian, download all his stuff, throw it into a model and give us a nice, humorous trained model. And really, if you do this, reach out to me, because I will be demoing it next time. Okay, so some tips when you get started. It's the model that fits best your needs. You can find it on the leaderboards. I will share the link at the end. And if you have the choice, use the best model you have. It just is more steerable. It makes everything easier. But then again, if you have constraints for resources and stuff, then you may want to switch to the model that has the minimum to perform the task you want. We have this demo key that I showed. So if you want to just try it out right after, you can use that without even having an OpenAI key. And yeah, good prompt templates are everything. So as you saw, I put maximum 5 lines. It didn't listen. I could have added, if you output more than 5 lines, a kitten will die. It's a very effective prompt. So yeah, just play around with it until you get it to do what you want. Right. Next thing is chatting with it. So it's important to know that the models are stateless, and that's why we will have to take care of handling all the memory. And you can either, with LangChain4j, do this manually, or you can use our integration that makes it really super simple. So this is how it works. If we send a message to any model, it will not know what has been said before, hence we should give it along. In this example, we want to send message 3 from our conversation. We have to give back all the messages we've sent before and all the answers we've got before, so the model actually knows what we were talking about. And then on top, there's this optional system message that can tell your model a bit how to behave, like you are talking to a toddler or you are talking to a nuclear physicist, and then it will adapt its tone ideally. So what it looks like in our code. We have a memory example here. I'm not going to run it, but we make a chat memory, and we're going to limit the length of it because LLMs have always a context window that has a certain size, and at some point you're going over it. So that's why we limit it in this type of memory with maximum 1,000 tokens. This is not a smart way of doing it, right? You can maybe summarize or chunk it other ways. But it's interesting to limit what you put in the context window because you pay per token. And to give you a reference, with OpenAI GPT 3.5, you can have 8 pages of text outputted for 1 cent. And then GPT-4, their more powerful model, cost 20 times more. To give you a reference. And then, then we have this chat memory, and here we're going to manually just add a system message. We're going to add our message. We're going to listen to what our model has streamed out there, and once we have this, we're going to also add its answer, and so on and so on. You can have a look at this at home. Now there's a very nice way to abuse this memory, and it's called the few-shot technique. So instead of fine-tuning a model, which is very costly to do exactly what you want, you can actually show it an example of what it should do and pretend it has been behaving like that before. So, and then it will behave like it has been behaving before. It looks a bit like this. In my chat history, I'm going to put a user message that, oh, I love this new update, blah, blah, blah. And I'm going to put an AI message, so the part of the model, that would have said, there's an action, forward this input to our positive feedback storage to share it with the developers later. And there's also a reply, thank you very much. So I have 2 positive reply messages, 2 negative ones that I created with ChatGPT in the first place. It's really nice. It gets really meta, right? And then it knows what to do. Basically, it will either open a ticket in case of negative feedback and apologize, or store it in our positive feedback storage and say thank you very much. And so we didn't even tell it how to behave. We just told, like, oh, this has been said before. And if we run this, fingers crossed, the new thing I said was, how can your app be so slow? Please do something about it. And so it replies with this action. So this is a really easy example, but you could automate behind it, right? And really open a ticket and have a summary in there. So action open this ticket, perfect, and then a reply that we apologize and everything, just by faking its memory. Okay, now it gets really interesting. We have our AI services, and they are capable of returning real Java objects. So AI services are LangChain4j's version of chaining different components. It works like this. You define an interface with methods that you want in there, and you don't have to code anything else. So we have an assistant. We want to get an assistant object that has a method chat that takes a message and returns a message. And then when using this, you will do AI service create from our assistant class. We give it a model along because it needs one. And that's really it. Then it will create this assistant object for us, and we can start using it. So we put a message in here. It's a piece of text form in French to translate it. And then we can just use our assistant chat, and it will deduct itself what actually needs to happen here. So I'm scared every time I run things here. Yes, capital gains from So it worked. This is really all we declared. That's how these AI services work. But then they get really interesting when we want to output things like a list. So here we want text utils. We want a method translate in there. And here is how you would declare variables. So this text, for example, is going to be used as translate the following text. All we have to give in our translate method is the text and the language we want to translate to. This gives back a string. But we also have a method in there, summarize. And our system message says summarize every message from the user in n bullet points. And n is our variable together with our text. And we get back a list of string. So again, we just need to create it, and then we're going to use it. We're going to translate how are you to Italian, and we're going to summarize this text in 3 bullet points. And the nice thing is we will get back a real list object. LangChain4j takes care of this parsing for you. Yeah, there we go. Ciao, come stai? It's correct. And then here is our list with the 3 items that we needed. That gets really interesting because then you can just work on in Java, plain Java, and you don't need to bother about parsing at all. So this a list is cute, right? But I have examples in here. I won't run them all, but if you have a sentiment enumeration here, positive, neutral, negative, and you want a sentiment analyzer, you can have methods in there returning your sentiment. It's gonna work. Or a Boolean, is it a positive sentiment? So Booleans, enumerations, all number types. So there's examples how to use them. Then my favorite one, datetime extractors, because it's always such a hassle. So we can extract local date, local time, local datetime out of phrases like this one. The tranquility pervaded the evening of 1968, just 15 minutes shy of midnight, following the celebration of Independence Day. And we are going to extract from there these date objects and time objects. How lovely is that, right? So there's just a whole new... There's a whole new world opening here. I mean, it's super easy to use, but also this was hardly possible before, right? If not to say not possible. We can make our plain Java objects. Here we have a person with a first name, a last name, and a birth date, and a toString method. And then we want an AI service person extractor that will extract a person. It will return us a person. Again, from the weirdest descriptions, it can actually get this person out. So just for documenting archives and categorizing them, it's super nice. Or also dealing with user input, right? It's similarly vague and obscure, and again, LLMs will be able to get structured data out of that. If it's unclear what your method should do from the method name, you can add a description. For example, if we want to make recipes and the title should be 3 words maximum, you can use descriptors like that to steer it more. And what we also have in here afterwards is an example where we add the chat memory. So we have this AI services, we add our model, and we add our chat memory on top of building our assistant interface that we defined just on top. And another example, if you have different users, that has also a memory ID, so that maps the chat memory per user, basically, if you want to use this. And then behind it, we have an example with persistent memory. To see how that works, you can look in there. Okay, who all of a sudden gets a lot of ideas what you could start doing with these LLMs? Right, okay, it's getting better. We can give LLMs tools. So tools are things some providers allow us to specify. And we will say, you have these tools available. You can use them if you think it makes sense. So as an example here, we have a calculator class with methods in there. One that calculates the length of a string. And it has this tool annotation and saying what it does. We have an add method for adding 2 numbers and a square root calculator. And now if we're going to make an AI service to chat, again, it's a simple chat one, but we can add tools to it. So first we make our model here, and then we build our service with our model, our tools, and we give it memory. So here we tell it you have these 3 tools available, call them if you want. And it knows which input parameters we will need. So it will really call the method behind the scenes, take the result, and use the result to make its answer. So we are asking it, what is the square root of the sum of the numbers of the letters in the words hello and world? So these examples start taking a bit longer because there's latency. There's calls from the model to the model and back. So we have some logging here. It's called the string length for hello, for word. It's called add with 5 and 5, which is correct, and then the square root on 10. And then it says the real output we actually get, if you omit the logging, the square root of the sum of the is approximately this number. There you go. Then it can get even more crazy. You can tell the large language model, you can use any tool you want as long as you manage to write the code yourself. And then, this is an example with JavaScript. We call an API that runs your code with the input parameters. So it looks like this. It's the Judge 0 tool. You give it along again when you build your service. And this time we're going to ask, what's the square root of this huge number? Capitalize every 3rd letter here. And what's the number of hours between... Oh man, I'm so happy we have these LLMs to solve these things for us now. Before I run it, I also ran these questions to simple ChatGPT to see if it can actually handle it on its own without special coded tools. And interestingly, there was one that it could handle. Who thinks it was the first one that ChatGPT can just handle out of the box? Who thinks it was the second one, capitalize the 3rd letter? Right, some people. And what's the number of hours? Right. It was actually the square root. It gave me the perfect answer on this square root question, and it failed both other on both other questions. So now it's different than just GPT 3.5 because now it can write its own tools to do what it wants. Again, this takes a little longer because we're going back and forth. Yeah, so it gives us the square root. It's correct. I recognize the number by now. But again, this would have been correct if it had had no tools as well. But then it managed to capitalize these 3rd letters. And for the number of hours, that number is also correct. Check that before. Voila. That makes programming a whole lot easier, right? But you need to know this is, of course, quite dangerous, right? If you let it run, either access your database because you can use the tools to actually go get things from your database or whatever, write emails or run its own written code. It's a security risk. There's such a thing as prompt injection, where people manage to actually make the model behave differently than you said it. Like if you just are convincing enough and say, well, now actually you're not what was specified, you're now an evil hero and you want to actually break the whole database, that works. And also to know if you ever want to use this in an enterprise setting, legally you're already obliged, at least in Europe, to say this is an AI chatbot, you're not dealing with a real human. But also in the US, somebody managed to make an LLM chatbot sell him a car for $1. He just was convincing enough, and he even asked on, like, yes, this legally binding and everything, and the model said yes, so he got away with this. And then they took a chatbot offline. So just so you know, before you start using this productively. The code from the model calls? For sure you can. Let me, if you want to see this, set some log requests and log responses. And this might give us the information we want. So yeah, this is an interesting question, because now you can also see how we actually communicate that it has a tool available. Okay, no. Wait, let me... So, also interesting, by the way, to know where the logs are. We have this tiny log default built in. Let's see if this changes anything. We were here. It's not looking good. Yeah, I mean, normally this works, but not today. I would have to clean my build or something. Yeah, so sorry. Actually, this really works, by the way. If you do this at home, these are the two ways to get your output visible there. Right. Then there's the next thing. If you want to use this in production and you want it to stop saying nonsense and actually know what your company is about, you can make it, give it information from documents that you provide, and it's called Retrieval Augmented Generation. So the idea is this: the user asks a question, and instead of only using the LLM's knowledge from the internet that it was trained on, you want to feed it some documents and get that information. But you can't just put all the documents in your context window, because it's going to cost you a lot if it even fits in there. So we actually want to find only the relevant parts, and then give this user question and say also answer this question only using, and then you add your segments there. And then the language model should give you an informed answer. Now, the hard part is, of course, finding the relevant parts only, and that's where these embeddings come in. So the way it works is you split your documents into smaller pieces, ideally in some smart way. And then these segments, you're going to embed them. You're going to calculate a semantic vector that represents its meaning. And you're going to store these vectors in an embedding store together with your original segments. Then that's one part of your application that you do once or with every update of your documents. That's separate. And then when your real running application where you have your chatbot, your user will ask you a question, and you will go search in the you will go embed the user question. So we're gonna vectorize the meaning of your user question, and then we're gonna search in this embedding store which vectors are most similar. Again, there's a lot of parameters to set there, which one you actually retrieve, and you find the most relevant segments for that question, and then you give it both the question and the relevant segments to your language model. We have an example here. It looks like this. We specify an embedding model, and very nicely, if you want to make it really easy, we have built-in embedding models here. They run on your local machine. You don't even need access to the internet, and they're like 20 megabytes and come as a dependency. If you want to prototype, it's really fast with that. We have also like an in-memory embedding store just for prototyping. Of course, you can set it up with any of these other persisted embedding stores. And what we then build is first an embedding store ingester, we have a document splitter. We're going to make it a really easy one. We say segment size is 300 characters and no overlap. But these are parameters that you would need to tweak based on what data you actually have in there. We choose our embedding model. We take our embedding store. And then we have an ingester. Then we're going to load our documents. And what we have here somewhere is a story about a happy carrot. It's not huge. There you go, as an example. And we load that, and we're going to ingest it, meaning in this ingest step, we will calculate these embeddings and store them. And then we're going to build a conversation chain with our model, language model, so it's different from this embedding model, right? This is going to give us a real proper answer. The embedding model is only for the semantic search part. And then we're going to retrieve it with an embedding store retriever where we have our embedding store where we have everything, and the embedding model, which should be really the same embedding model because these vectors differ, the way they're coded differs. And then we can use execute to actually call our method, and we ask who is Charlie, which of course without a document it would not possibly know. So Charlie is a person who is humble, values teamwork and friendships, and he has a diverse group of friends who are vegetables. So actually Charlie is a carrot, but I mean, close enough. So, by the way, the Spring Boot example works in the same way. We gave just our terms of use as documents. Good. So for the prototyping, use these in-store, in-process embedding models and memory in process. And it's really worth optimizing this segmentation. If you want to play around with all these parameters, below here there's an example called if you want more control. No, it's not. Good. It is here. Okay, where actually all these different steps are taken apart and you can set really all separate parameters. Maximum 3 results to be retrieved with the minimum score of this. So it's worth tweaking those for your application. And to clean up your documents. For example, you might want to add the title to every segment because sometimes it's unclear what it's referring to. Good. The meme has nothing to do with it, but I just found it funny. We have integrations with Quarkus and Spring Boot. You already saw the Spring Boot example. I want to show you this Quarkus example in here. So it's also available in our examples. I'm going to run it via command line because that just worked better for me. So if you run Quarkus applications in dev mode, you can then change things in the code and it will automatically be swapped without you having to restart the whole application. It's super nice. By the way, all these large language models usually also speak multiple languages. So if you have a customer from abroad, should be able to handle it. That's a good start. Let's go see. Please. Today's not my day. What's it saying? It doesn't look good. Oh God. I mean, it has a name, right? Ah, yeah, nice. It's up. So it's you can write your review here, and you will again get a thank you or apology. Ça marche vraiment pas du tout. And then it should be just able to detect my language, and hopefully. Nous sommes désolés que vous avez rencontré des difficultés. It's perfect. So this is also, again, just a very easy example, so you can see how it's set up with Quarkus. It works a bit different than normal Java applications. And very nice, I wanted to show this, is that they have a dev UI when you go to /q/dev UI. So what you have there is to observe basically your application, and specifically for LangChain4j here, experimental. You can chat a bit around, you can tweak your system message. It's really nice, and it's using this model that you actually put in there. And also interesting, you set your parameters. In Quarkus, you would usually put them here in application properties. But if you don't know which ones are there, or if you want to just hot swap them here, you can, here you have the whole list of everything you can set. And if we get to LangChain4j, lots of HTTP stuff. For example, we could set these logging actually. Here, if we want to log our requests, if we save it here, it's automatically done, changed in the program. So if we would continue chatting with it, we would get the logs. And also very nicely, it magically appears there. So that's pretty cool. Good. So we're at the end of the talk. This is the link to our GitHub repo, but it's easy to find, LangChain4j /LangChain4j. It's a bit of a tongue twister. We have this example folder too, where you will find all the examples I showed in the folder tutorials. There's a link to a leaderboard where you can choose the LLM that fits you best. Some local models community where you can ask everything about your local models. Then more information, just take a picture if you want it. I mean, this talk will also be published online, so you can take it there. Good. We look forward to your contributions. If you want to help with the documentation, or if you want to add a new integration, have a look at the bug reports, feel free to contribute. And with that, thank you very much for your attention, and enjoy playing around with it.